So hi there, everyone, and thanks for having me at this Python Data Science Day. It's exciting to follow Jeffrey. I work with him, and we'll take a look in a little bit at Data Wrangler in another form in Microsoft Fabric, which is the product I work on. The topic of the presentation today is Python programming in Microsoft Fabric. Fabric is a new unified data platform that combines multiple Azure solutions into one analytics offering for the era of AI. I'll talk a little bit about what that means. My name is Eren, and I'm a product manager on the Fabric data science team. So that's one of several workloads that are combined into the product. The focus of this talk is going to be providing an overview of Microsoft Fabric that's geared more toward Python programmers as opposed to Spark developers, who are a lot of our audience. I'm going to discuss some features like collaborative code authoring with Fabric notebooks, custom library management with Fabric environments, and machine learning with Fabric experiments and models, which are standardized on MLflow. One of our main value propositions is a simplified Spark experience, as I said, with session startup times in a matter of seconds. But Fabric also facilitates a lot of Python development with tools like Data Wrangler, built-in, Copilot, assistants, and more. If you stick with me, you'll get a walk through some common workflows in Fabric and a preview of upcoming features that are geared toward Python developers. So we don't have very long, but I did want to begin just with a brief summary of Microsoft Fabric, which went into public preview last year at Build and became generally available last fall at Ignite. Our CVP, Arun Log, likes to say that, in a world awash with data, big data coming from everywhere, our organization is striving to help enterprises turn that data into some sort of competitive advantage. These days, we know AI is driving a lot of innovation in the analytics space. The good news of that is that businesses have tailor-made products for every element of their workflow. If you take something like data ingestion, data preparation, data warehousing, there are so many tools that are cropping up to address those needs. The bad news of all this innovation coming with AI is that there's fragmentation that results from so much different tooling. Different products have different subsystems. There are different classes of products, different vendors, and integration for businesses can be really complex, fragile, and expensive. So that's where Fabric comes in. Our goal is to provide one unified data platform with best-of-breed capabilities across all of these analytics workloads. So we want to reduce the fragmentation of the modern data stack and make it easier within business organizations for different people, different roles to collaborate. We combine a range of workloads in Fabric for everything from data ingestion to data engineering and data science to business intelligence and visualizations with Power BI. And this is all one AI-powered platform built atop of one lake and purview with a single sign-on, a single navigation model, a single security model, and so forth. So we brought Power BI, Synapse, data engineering, data science, data factory, the next generation of all these experiences into one price performant and easy to manage modern analytics solution. Fabric is open at every layer with no proprietary lock-ins. We empower business users with deeply integrated Office and Teams experiences. So, it feels kind of like you're working together on a PowerPoint presentation or on a Word document, but instead of one drive, it's one lake that you're working on top of, bringing users with different roles and experiences into one place. And we deliver AI copilots to accelerate productivity across analytics so that you can discover insights and create, custom solutions with your own data. One part of this is data science. So that's what my team within Fabric focuses on. We're working to make machine learning more accessible to more users and particularly business users. So our goal is really for data scientists and developers to work alongside data engineers, but also business experts and domain experts, the people who really sort of need to analyze that data and then present it to their own teams within enterprises. During the next part of this session, I'm going to show off some of the features in Fabric that are most relevant to Python programmers, from that co-authoring experience in notebooks to our machine learning and model and experiment tracking solutions that are built on top of MLflow. Data science in Fabric overall is designed to provide easy and secure access to lake-centric data. It's designed to be developer-friendly, so to have rich, easy experiences for you to work in a notebook, in a cloud-based environment, or locally in the IDE of your choice. We want to have rich ML tools like our Synapse ML library. And we want to promote collaboration again. So the ideal is that it's easy for different members of an organization to hand off work from one to another and for businesses to collaborate in that way. So unified data access, secure sharing of code and models and experiments, that's all really key to what we do. Before I take a look through a kind of tasting menu of different features for Python programmers, I wanted to pop into the live product for a moment, if you'll come with me. So I'm going to switch screens one sec and take you into Fabric. So this is the view you'd see as a data scientist. We have these persona optimized experiences where, in bringing together all these different tools, we still want to allow people to personalize. So in this case, the data science view is really optimized for the ML model and experiment artifacts, which are dedicated items that live inside a Fabric workspace, and also the notebook, which is its own artifact for code authoring and filling in these ML models and experiments. We also have an environment artifact, which I'll talk more about, and some other artifacts that are coming into play. So you'd address this by working on a data science project within Microsoft, and you'd have a workspace for that. This is a pretty lightweight concept. So on the side of the Fabric screen, you can navigate between different workspaces for different projects. As you see, you can have different artifacts live in that workspace. So we have a notebook, an ML experiment, and an ML model. It's easy to get started with new artifacts, to upload data, browse from different places, to create deployment pipelines, manage access, and sort of configure your workspace settings. And then from there, you can go into, say, a given notebook where you might be training a model, accessing data, from an attached lakehouse. Again, all unified, all within Fabric. You might be deploying that model or generating batch predictions with the model. You can write those predictions back to the lakehouse, and then you can read them, from Power BI or have them served to a visualization layer. In this view, we have a machine learning experiment. So this is kind of the logical container for a lot of the work that data scientists do. You're going to be familiar with this if you use MLflow, an open source platform for managing the machine learning lifecycle. We have a lot of those, metrics and parameters logged here visually to make it easier to work on that process. You can view a run list for your experiment, and you can save any run of an experiment as a model version. And so then in your model, you would be able to look at both the underlying files of any version, see the parameters and the details, and also embark on a series of pretty quick steps to do things like deploying the model, or copying code for a batch job. So I'm going to hop back to my deck and show you some of the features sort of tailored more specifically to data scientists. The first is our notebooks. So our notebooks in Fabric are going to be familiar to anyone who's worked with Jupyter, but here they're optimized for collaboration and data connectivity. So we have real-time co-authoring experiences that let you collaborate with your team members on things like machine learning workflows, the same way you would on a shared Word document or a PowerPoint deck. So there's authoring at the same time, but there's also commenting and tagging with review and comments. It's really kind of similar to Office in that sense. Our notebooks are also seamlessly integrated with the rest of the data in Fabric, the data sources, so that you can connect to more than 100 sources really in a matter of clicks, browsing data, in the cloud from different places. You can attach lakehouses, as I showed, to a given notebook, and drag and drop in code snippets really simply that let you explore that data. And our notebooks are also hooked up with source control and Git. So, you can back up and version your work, revert to previous versions or stages of that work, and collaborate, on Git branches as well. And that's all kind of wrapped up in this artifact, which is the sort of first stop for developers, writing code to populate things like experiments or models or, other machine learning artifacts in the workspace. Now, I hope you'll forgive me during a Python session for doing a little plug for Spark, but I did want to talk about our Spark experiences briefly because in Fabric, they're designed to be really easy. So this is a Python session, but I did just want to call out that in Fabric, you can get started with Spark in a matter of seconds. Our starter pools come pre-wired, so that spares you the work of having to set up clusters or do a lot of the work that you might have to do in a kind of platform as a service product. And for more complex use cases, you can still go and create new pools with customized settings. And take advantage of things like our high concurrency mode to have Spark sessions kind of span multiple notebooks. And again, although much of Fabric is geared toward those Spark use cases, we're going to soon offer a lighter weight native Python notebook that more closely resembles the kind of experience you have working in Jupyter. So you'll be able to switch between built-in kernels and Python versions in Fabric and to transition seamlessly from small scale explorations in a Python notebook to larger scale operations in Spark. And all the while, you can maintain a really tight integration with your business intelligence ecosystem. Alrighty, the next topic that I wanted to just take a look at was the Fabric environment artifact, which I showed a little bit in the live tool. So in a Fabric notebook, you can manage Python and R libraries the same way you would, in another place with inline installation using commands like pip install. But you can also customize and configure your workspace with the use of these dedicated environment artifacts. So there's a UI that allows you to kind of track the different installations, consolidate all of your settings for development in a single place, and then attach these environments as their own artifacts to different notebooks. The environments are integrated with CI/CD and our APIs for tracking and management. Is really just a way to kind of unlock additional flexibility for your projects and also define it in a way that persists in the UI and is visible as its own sort of thing, an artifact that kind of spans the different development environments in Fabric. Now, the features I'm showing off live inside of Fabric, as you've seen, but if you prefer to work in VS Code dark mode, as a lot of people do, we've got you covered. From a Fabric notebook, you can easily launch the VS Code extension and take advantage of just that amazing IDE to explore your Fabric workspaces and your Fabric notebooks and Spark jobs and lakehouses. So, you can work in the browser or locally, and soon we'll be offering debugging support for the remote VS Code experience as well. We're big fans of VS Code, and we really benefit so much from the work that DevDiv does. It's crucial to us to be able to let our customers use the tooling that they prefer, and VS Code is really state of the art there, of course. While I'm talking about VS Code, I do want to give another shout out to Data Wrangler, which if you caught Jeffrey Mew's session just before this, you'll be familiar with. Data Wrangler is a VS Code extension from the geniuses at Microsoft's developer division. It allows you to seamlessly explore and clean data in an Excel-like environment that is really immersive and visually friendly. So it's designed in part for newer data scientists and developers to kind of get onboarded to the work of data preparation, but it's also designed to facilitate, work for even experienced developers, because data preparation and exploration really can be a hassle and a drag. So there are a range of features here, as Jeffrey demonstrated, to help users identify and address errors or inconsistencies, fill in missing values, create new columns, one-hot encoding, you name it. There are built-in visualizations in the headers of these columns, and there's a library of code operations that can be applied in a couple of clicks. So that's all done from the UI, but crucially, as you're transforming the data, you're getting steps in Python. You're getting the code that corresponds to those steps, so everything is transparent and reproducible, and you can land it back in the notebook afterward, as this animation is showing. So really what we're doing here is streamlining data preparation without sacrificing the reliability and the familiarity of Python. And we're very lucky to have been able to collaborate with Jeffrey's team and DevDiv to make Data Wrangler available inside of Fabric, where I also want to point out you can open both Pandas data frames and Spark data frames. So we give you the ability to take a larger data frame and sample it down and really produce both Python code and Spark code. You can do kind of translations seamlessly. So Data Wrangler in Fabric will translate your Pandas steps to PySpark if you're working on a PySpark scenario on a Spark data frame. And this makes it much easier to handle a very familiar problem of kind of switching between Pandas and Spark, like scaling up from one to another when you're working on data transformation. A lot of customers have talked to us about that being a kind of familiar hassle, sampling down to do your analysis, but then you need to scale back up to apply, whatever steps you finalize to the larger data set. Data Wrangler tries to make it easier to do that and to switch from those sort of lighter weight exploratory analysis tasks to heavyweight transformation on PySpark. So there's support for custom operations, so we handle a lot of translation. And we're also going to have new features coming in, including the ability to translate natural language into Pandas or PySpark code. So really taking advantage of AI to just make things easier and more seamless for data scientists working in Fabric. Once you've done that, cleaned and prepared your data, Fabric makes it easy to build machine learning models too. So this is really a lot of the crux of my work and where we get excited. The data science product is built atop of MLflow. So it's a versatile, open source platform for managing workflows and artifacts across the ML lifecycle. You can get started in Fabric from a set of data science samples that we have, which are end to end for common use cases across Python and R. You can manage ML experiments and models as dedicated artifacts in that Fabric workspace. So there's a UI that goes along with each of them, and you can manage and manipulate those artifacts using the UI or using your notebook. We have experiences to compare experiment runs and register model versions from experiment runs. And we have support for auto logging too. So if you're writing code in a notebook, MLflow is going to really just track those metrics and parameters for you and will land them in your artifact without much hassle. And then once you've trained and registered a model, you can use it for batch inferencing from your notebook or from the UI. There's a code first application, where you use our predict function to, basically apply your MLflow packaged model for batch predictions, just, with a few different parameters. Then you can write those predictions to your lakehouse or, place them wherever you need to. There's a low code counterpart for predict, our function, where you can kind of just go through a wizard in the UI and specify where you want to take data from to put it into your model, how you want to map it from your source data to your model, and then where you want to land the destination data. And then very soon in Fabric, we're also going to be allowing you to deploy Fabric models to real-time endpoints in a matter of clicks. So we built a solution on top of a container service that lets you prop up these models basically to just be accessed via simple REST API calls, and we'll have a UI component for that too. So taking things like deployment in real-time scenarios and stripping away a lot of the configuration, so it's very easy to get started out of the box once you train the model. It shouldn't take very long. I would be remiss not to talk about AI. So let me just switch the slide. It looks like it's getting stuck. Give me one moment. I think my screen is freezing, but there we go. This is a big topic, so maybe just adding a little anticipation. Across Fabric, we're building in experiences that allow users to take advantage of next generation AI with their data. So for my team, thinking about data science and data engineering, we want to accelerate tasks like data exploration and prep and ML modeling. This starts with copilots that are built into Fabric experiences to accelerate your productivity and help you take advantage of your data. We're also enabling users to tap into Azure OpenAI models and AI plugins to deliver, those experiences. So again, AI-powered insights that help you understand business data, but also help you bridge the gap between insights related to that data and then, the corresponding actions. Alrighty, I think I'm getting a little bit of lag, but just bear with me while I get the next slide up. There we go. So copilots in Fabric take the look of, a kind of chat-based assistant by your side at every stage, but you can also leverage Copilot directly in the notebook. So here, the idea is, you can have a chat pane that you sort of talk to, or in the context of a code cell, you can generate code using the AI connection and count on the AI to be aware of the data in your lakehouse as well as the data in your data frame. So, magic commands for natural language answers is one obvious benefit of this, but there's also that kind of more familiar chat-based experience. I wanted to show off a little bit of a demo prepared by one of my teammates for how Copilot can help accelerate data science and data engineering. So I'm going to switch to that now and hope that the audio takes over.
Let's take a look to see how we're integrating Copilot for data science. Here I am in a notebook with the same e-bike rental data that we've been working with. I've loaded some data frames, and I could start writing code manually, but let's see how Copilot can help. Let's open up the Copilot task pane. I'm going to collapse this pane over here so we can see more of the notebook, and let's get started. Right away, I have some suggested prompts to help me understand my data and how to analyze it. Let's ask to see some suggestions of how to visualize things. I get a good list of options, and I could ask Copilot to help with any of these. First, I want to just get a basic column chart of trips by station. All I need to do is ask Copilot for help. I can enter my prompt, and Copilot looks at my data and generates the code for me. This lets even someone who's just getting started with Python to get up and running quickly. Now that I have the code, I can insert it into the notebook and run it. Right away, I see that the San Francisco Caltrain station has the most trips starting from it. That's interesting, but now let's ask to get a heat map of trip duration between start and end stations. Again, Copilot is going to take my prompt and generate the code for me. Let's insert it into the notebook and run it. And now I have a pretty interesting heat map. There are a few outliers which we can zoom in on, and it looks like San Jose State University has more long trips starting there than on average. And as you can see, Copilot is doing a great job of just letting me ask questions and taking care of providing me the code so I can just play with my data. Now, asking questions from the task pane is okay, but I'd rather work directly in the notebook. Fortunately, I can use Copilot in a notebook cell just by typing %% code. Let's ask for help creating a forecast for next month using the Profit Forecasting library. Copilot has generated the code. And you can see it takes quite a bit of know-how to know how to use this library, but Copilot has taken care of figuring out how to use it with my data. So now I can just run the code. And just like that, we have our forecast. Let's look at the shape of the data by asking Copilot for some visualizations of the output. And now we have a line chart of our new forecast. I could keep iterating and playing, which is really fun using Copilot, but let's finish off by writing the results back to my lakehouse. Copilot is going to truly democratize the ability for everyone to be able to work with data in advanced ways. And as you can see, Copilot gives everyone a bit of data science superpowers with Microsoft Fabric.
Alrighty, so with that, I did want to wrap up. I know that it's a busy program and we might be a little bit over. So I want to thank you all for listening. There are so many experiences that I wish I could get to or talk about in greater detail, but I would love for you to take a look at our documentation to learn more and try out Fabric yourself. And thank you again for having me at this session.